What's up, everybody? It's Dr. J, and today I said yes. Today we are talking about Lewis structures. All right, so we're looking at CH2S. All right, so the first thing we need to do is figure out the total valence electrons. Real fast, shout out to LSU, man. Y'all see the bracelet? Shout out to LSU. I'm a model right there. So yeah, we need to figure out the valence electrons for carbon, hydrogen, and sulfur, right? Two ways to do this. We could either look at the periodic table or do the electron configuration, which in this case, let's just do the electron configuration. So the electron configuration for carbon is 1s2, 2s2, 2p2, right? In this case, having 4 valence electrons in my outermost shell. Okay, we're going to do the same thing for our hydrogen, 1s1. I got 1 electron in my 1s orbital, so that means I only have 1 valence electron. In this case, my sulfur, right? In this case, everybody, we want to make sure that we understand we're using the atomic number, right? The atomic number tells you how many protons you have, or you got a neutral atom, how many electrons you have. So we're just going to fill in our orbital, and we see the electron configuration for my sulfur is going to end with 6 valence electrons, with 6 being in my outermost shell and my 3s, right? So once we figure out all of our valence electrons for our compounds, we can now just add them all up because we're trying to get the total. We need the total valence electrons, right? VE. So we just figured out, right? Carbon has 4. Hydrogen has 1, but I have 2 hydrogens, so that's 1 plus 1. Shout out to Beyonce. And then I got sulfur, which in this case is going to be 6. So if you add up that 4 plus 1 plus 1 equals 2, okay? And then you add that up with 6, you're going to get 12 total valence electrons. So I'm just going to box that to let you know that's how many electrons we actually need to use today. So when it comes to actually drawing out this Lewis structure, right, you need to always start off with your what? Skeleton, right? Start out with your skeleton. So in this case, my carbon is going to be in the middle. So next, we need to figure out who's going to be in the terminal positions, the outside positions. Hydrogen is going to be in those terminal positions. Always put the hydrogens in the terminal. And then sulfur is in my other terminal position. The reason being, sulfur is a little bit more electron negative than my carbon. So carbon's in the middle, 2 hydrogens on the outside, sulfur is on the outside too. So now we need to use our 12 electrons. I'm going to put 8 around my sulfur because it needs to satisfy the octet rule, right? The octet rule means that you need 8 surrounding electrons. Sulfur and carbon follow those. Hydrogen follows the duet rule, so I only need 2 electrons around there. If I look at my hydrogen, it's satisfied because the lines mean there's 2 electrons. So both of those are satisfied. My sulfur, however, has 2, 4, 6, 8. That's also satisfied, but my carbon, look at it, not satisfied because we only have 6, and I've already used all of my 12 valence electrons. So I got to figure out a way to use 12 valence electrons, but also satisfy my carbon octet rule. All right, this is where it gets a little bit tricky, but here's the secret, everybody. What you're going to have to do is you're probably going to have to make a double or triple bond if you don't have enough electrons. Let me show you. So right now, my sulfur, right, put it in that position. I put in my electrons 2, 4. But if I'm going to add this double bond, now my sulfur will be what? Satisfied, right? 2, 4, 6, 8. My hydrogen is satisfied at 2. And my other hydrogen is satisfied at 2. Now let's look at my carbon, because now my carbon has 2, 4, 6, 8, and it's satisfied. Everything is satisfied following our octet and duet rules. Key thing I want y'all to pay attention here is that we had to use a double bond to figure out, right, and use all of those 12 electrons. Okay, that's a trick thing, right? So you don't have enough, use a double or triple bond.